I am going to go to screen share and show you my web page. Okay. I'm trying to find it. Okay, can you see my web page?
Yeah.
Okay, what you need to be doing is go to module 1, chapters 1 and 2. I'm going to click on that. So you will be directed to module 1 here. So if you go down, you can look at Zoom meeting 1, first day, second day, and third day Zoom meetings. So at the bottom of chapter 1 material, do you see quiz 1, chapter 1 here, CHEM 105? So that's where you need to be going and start working on, okay? So you have to watch the material on the Zoom meetings and then do the quizzes as we finish each chapter. Okay? All right, I'm going to go to chapter 1, to place where I left off last time. All right. Do you see, can you see my web page on PowerPoint?
Yes, sir.
Okay, that's where we left off last time. I'm going to start this from right here. Okay? All right, that's where I finished last time. We talked about matter. They are made out of atoms and molecules. We're going to look into details of atoms and molecules in chapter 2. All matter is made out of pure substances and mixtures. Substances and mixtures. Substances have only two types, elements and compounds. Elements have only one kind of atom. We're going to look into that in chapter 2. Compounds have more than one atom, like sodium chloride, water. One thing common to elements and compounds is they have fixed chemical physical properties. Compared to substances, mixtures have variable properties. Mixtures are made out of more than one substance. That means two elements or more, element and a compound and another compound is a mixture. For example, sodium chloride put in water, there are two compounds. It's a mixture. So mixtures could be homogeneous, heterogeneous. We talked about that. Homogeneous means they are uniformly distributed, all the particles are equally distributed, just like right here. There are lumps of regions in heterogeneous. We will be talking about this more. Okay, pure substances, which are elements and compounds, have constant composition. They cannot be broken down into other pure substances by physical chain. To break down compounds, you need to have chemical chain. An element is a pure substance that cannot be broken down by a chemical chain. So element is the ultimate stable particle in chemistry. Atoms are not destroyed in chemical reaction. For example, aluminum is shown in this picture. That's the green, yellow balls represent aluminum atoms. Other type of pure substances are compounds. They have two or more elements. They are chemically combined. Two elements, different elements. For example, in this picture, chlorine and sodium is combined with each other in 1-to-1 ratio. That's a compound is substance made out of two different kind of elements. Water is also a compound of hydrogen and oxygen. Now we're going to look into some problems about this type of classification matter. Elements and compounds are both classified as pure substances. Is it a true or false statement? Elements and compounds both are pure substances. That's true. About the compound, when a strong magnet is brought near a sample that contains both iron and sulfur, that sample has iron and sulfur in it. We don't know what form. The iron and sulfur are not separated from one another. So it should be a compound. If a magnet is brought into the sample, iron will get attracted to the magnetic field and could be separated. So this is an example of pure compound, a compound. So answer is not heterogeneous mixture or homogeneous mixture. So when you cannot separate from each other elements in a compound, that is a pure substance called compound. In this problem, sodium is highly reactive metal and chlorine is a non-toxic gas. When they are mixed, they form sodium chloride, which is essential for life. Which of the following statement is true when sodium and chlorine brought into contact with each other? So they normally react with each other. A compound is formed. If they are unreactive, then you have a mixture. Could be homogeneous or heterogeneous. So in this case, sodium and chlorine form compound, not a heterogeneous mixture. They form a homogeneous mixture. Homogeneous is uniform distribution of atoms in the sample. They form a compound. Sodium and chlorine typically are reactive, so they form a compound. They may form heterogeneous or homogeneous mixture. Okay, the answer to the question 27 is C. Nitrogen would probably be classified as a compound. would that be a element or compound? This statement say nitrogen is a compound. Compound have two different types of atoms, elements. Nitrogen has only one element. Therefore, it's a false statement. Compound cannot be broken into simpler substances. That's not true. Compound has two elements. It can be chemically separated into two simpler elements. So therefore, it's false statement. Weak mixtures are the combination of elements, two different elements, element and a molecule, element and a compound, or two different compounds. The component of the element of mixture can be present in any mass ratio. The components of a mixture depend on the person mixing it up. There's no fixed ratio. The ratio between two components could be anything. That's true statement. Chemical techniques are required to separate the components of a mixture. Normally, mixtures are separated by physical techniques, distillation, filtration, like that. So this is a false statement. Mixtures are not separated by chemical techniques. Chemical techniques are required to break down a compound into elements. That's a compound, it's not a mixture. Therefore, mixtures does not require chemical technique. The components of the elements of a mixture can be present in any mass ratio. That's a true statement. But the second part of the statement, chemical techniques are required to separate the components of a mixture, is wrong. Therefore, two statements, one of them are wrong, and statement combining them. That's false statement. So still the choice A is the correct answer. The choice D, components, elements of a mixture cannot be present in any mass ratio and chemical. So both are false statements. Therefore, totally D statement is false. So only true statement is A. When a sample of a particular solid is examined under microscope, clearly distinguishable, black and yellow regions are observed. So when you have, this is the example we talked about, iron and sulfur. That's a heterogeneous mixture. Clearly visible areas. That means sample atoms or components are not distributed homogeneously. Therefore, answer should be a heterogeneous mixture. So heterogeneous mixture is choice D. That's a recording was on the state of matter. This is one of the states of matter. How many states of matter there? Solid, liquid, gas. This is the solid state. Solid state has definite volume. It maintains its shape regardless of its container. Solid particles lie close to each other in regular pattern. In this picture, you can see the water molecules in an ice. Solid form of water is ice. So the second picture is a liquid form of water. They are still close to each other, but they can roll over. Therefore, liquid has a definite volume, just as the solid. But it has definite volume, but it has no definite shape. It takes up the shape of the container. Liquid particles are close together but not move past one another. Solid are staying in one place. Liquids roll over each other, but they are still close to each other. In the gaseous phase of water, which is steam, in gaseous phase, there's no definite shape. It assumes the shape of the container, balloon, whatever the bottle or container. It has no definite volume. It assumes the volume of its container. So these are the different properties of free state. Gas particles are very far apart. They are not close to each other. They move randomly in many directions. Let's answer some question of states of matter. Liquid, gas, liquid, solid, liquid, gas. Which statement is true of compressibility of a solid, liquid, and gases? Compressibility is you can change the volume. You already know gases are the only one that could be compressed. But the solid and a liquid are kind of a tricky issues. They are not both solid and liquids are not compressible. Liquids are more compressible than gas. That's false. Solids are more compressible, and that's false also. Liquids are more compressible than solid. In a way, it's easier to compress liquid as in a brake fluid. Therefore, little are more compressible, easier to compress liquids. Solids are more compressible than liquids. That's not true. The liquids are more easy to compress than solid. Therefore, answer should be C. Surface water on a lake or pond act as if the surface has a skin due to the property called water has a property called surface tension. Therefore, on the surface, it tend to maintain the skin of water molecules. So this is answer to that question is surface tension. Viscosity is the ability to flow. Higher the viscosity, slow for the flow. Condensation is gas to a liquid. Evaporation is liquid to a gas. Surface tension is the property that gives rise to the surface of water to behave as a skin, surface tension. In which state of matter do the particles are separated from each other and fill space available to fill all the space available to them? What do you think answer is? Answer is, I'm checking. Answer is C. Do you guys see it? The change from liquid to solid is called melting. Solid to a liquid is melting. Liquid to solid is melting. Change from liquid to solid is freezing. Reverse is melting. Therefore, freezing is the correct answer. The freezing point of a water is same as its melting point. These are reverse processes. They are the same. Freezing point is same as melting point. So answer is A. What is evaporation? Evaporation is liquid going to a gas. Sublimation is gas going to a solid. Evaporation is liquid turning into a gas. D is the correct answer. Now, the matter has physical properties such as boiling point, melting point, solubility, how much that substance get dissolved in solvent like water. A color with the sulfur is yellow color. There's a smell to substances, and matter also has a state of matter, has a state. For example, liquid water is liquid at room temperature. So physical change is associated with melting and melting point, boiling point, and freezing point, etc. Solubility is how much it gets in. Color is also. So melting point is solid to liquid, liquid to gas, boiling. The substance has freezing point of minus 20 degrees Celsius. Choose the appropriate classification from the list of responses. It's a property. Property has a value, numerical value. Solubility, 20 grams dissolved, that's a property. Change is a description of change. It melts to ice melts. It's a physical change. So therefore, that freezing point of 20 degrees is a physical property. Melted, substance is melted. Choose the apparent. This is a change of substance. There's no number to it. So that should be a physical change. C is the correct answer. The substance has higher density. Those appropriate classification. Density has a number associated with it. Higher density has a higher density value than the lower density sample. Therefore, it's a physical property. Now, on the other hand, chemical properties are also characteristic of substances, either elements or compounds. So reactivities of a substances, chemical substances, how they change to a different compound. So they talk about chemical reaction, flammability, explosiveness, reactivity, corrosiveness are all chemical properties. Chemical change is the chemical reaction that converts one substance to another. For example, hydrogen plus oxygen produce water. That's the chemical change. For example, in the picture, red balls are oxygen molecules O2 with hydrogen H2 produce water. That's the chemical change. So physical change and chemical change is easy to understand. Chemical property. A substance will explode if exposed to light. Explosion is a chemical change. Classification. Explosiveness is chemical property. Substance react with chlorine gas. React with chlorine gas. is the chemical change. Substance undergo chemical change. It is always true that it freezes. Freezing is a physical property. That's not answer. A solid is formed. Not always chemical reaction produce solids. It cannot a new kind of matter with different composition. That's the statement we are looking for. The substance you start with change to a different substance with different composition. Temperature of the substance increases. Even in a physical change, temperature could be, water could be heated up to boiling. Answer is C. We're going to talk about density. Density is defined as mass of a substance divided by volume of a substance. The most common unit for density is grams per milliliter. For gases, grams per liter. For example, you can calculate density of a sample with 73 point right here. Number 73.2 and mass is 61. How do you calculate the density? 61.5 divided by 73.2. So you get the answer 0.840 with 3 significant digits. We talked about significant digits. So we get the answer. Density is a physical property. Relates the mass of the volume to its volume. So density is a conversion factor. We talked about conversion factors. Conversion factor right here, which convert milliliters to grams. Then milliliters multiplied by density, get grams. Grams divided by inverse of density, you get the milliliters. So if you are given a question, milliliters of a sample given and density given, you can get the mass of the sample, vice versa. Milliliters could be converted to grams. Specific gravity is another property related to density. It's different. It compares density of a substance with the density of water at the same temperature. So specific gravity is density of the material divided by density of water. So when you divide density of a substance by density of water, the units grams per milliliter cancel out. And specific gravity is unitless or dimensionless. The unit numerator in the numerator and denominator cancels out. Specific gravity of a substance is equal to its density but contains no units. Okay, we're going to do a few examples. I'm going to go to the workout that I did here. Mercury metal that is liquid at room temperature. The density is 13.6 grams per cubic centimeter. What mass in pound? 1 quart of mercury. The conversion factor given. 1 liter is 1.05 quart. 1 pound is. So you have to convert grams to pounds and liters to centimeter cube to cancel out centimeter cube. Here we start with that 1 quart. So less final and as is how many quarts of mercury. You start with 1 quart of mercury. Then you convert it to liters. 1.1 liter is equal divided by 1.57 quart. That's the conversion factor here. So then we convert liters to cubic centimeters. Then cubic centimeters is converted to grams. That's the factor labor. So then grams is converted to pound. The question is how many pounds in 1 quart of mercury? Answer is 28.4. This is an example of all the knowledge we gain from this chapter, converting and calculating using conversion factor. The second problem, problem number 167, is also same. Xenon is a gas found in automobile headlights. They are asking the same question for 1 quart of xenon. How many pounds? Just like the mercury question. You start with 1 quart, go through the same thing, you get 0.0112 pounds. Answer is A. Which of the following relationship between density expressed in grams per milliliters and specific gravity? The difference between density and specific gravity, they have the same numerical value, but specific gravity have no dimensions. It's unitless. We talked about it. Now we're going to talk about energy, the last topic on the chapter. Energy is capacity to do work. If you are energetic, you can do a lot of work. Energy is found in the nature in 2 forms. Kinetic energy, expressed by moving objects. Potential energy, depending on the location, position of an object on the top of a mountain as potential energy. So there are 2 common types of mechanical energy, kinetic energy and potential energy. We find 2 forms of energy. Energy is mainly kinetic energy, mechanical energy, light, heat, and electrical energy. These are 1, 2, 3, 4, 5 forms of energy. No, 1, 2, 3, 4. 4 forms of energy which are kinetic. Mechanical energy is kinetic. Mechanical energy moves the object. Heat also, motion of particles in the substances increase with heat, that's kinetic, moving, vibrating. Light also behaves as particle. Even though it's difficult to imagine light as a particle, when light is described as particle, it's called a photon. Photon of light is particle of light. Heat is motion of atoms in a sample. Electrical energy is movement of electrons. That's a kinetic energy. Moving electron has energy that's converted into other types of work, heat, lighting a bulb, etc. In chemistry, most important form of potential energy are chemical energy and nuclear. Chemical energy is potential energy stored in bonds. Bonds, placement of bonds, bringing in together, give a potential energy to a molecule or in a compound, elements in a compound. Also, nucleus has potential energy due to their placement of neutrons and protons in the nucleus. When you separate them out, the energy is released, nuclear energy is enormous. But in chemistry, it's only the electron energy coming from chemical bonds, release energy. Chemical energy is stored in chemical substances, as for example in food such as carbohydrate and fat. When you burn glucose from the carbohydrate, get into your body, you produce energy, which is used as ATP for metabolism. Fat also is burned to carbon dioxide and water. These are the chemical potential energy in the bonds. Energy is given off one substance take part in a chemical reaction. When chemical reaction takes place, bonds are broken and new ones are formed. Depending on the relative energy of bonds broken, bond form, you can have exothermic heat given out or heat absorbed endothermic reactions. Energy always follow all kind of energy, potential, kinetic energy, everything follows law of conservation of energy. That's also called first law of thermodynamics, which is a statement of energy can neither be created nor destroyed. So only thing you can do is convert one form of energy to another. We're going to talk about heat form of energy and its relation to temperature. Heat is a form of energy, kinetic energy in the motion of particles in an object. It's not bulk kinetic energy, it's an internal energy inside a rock or inside your body. The particle comes higher the vibration movement of particles, it become high temperature, higher the temperature. Normally, heat is the energy that transfers when two objects of different temperature are brought into contact. There's no flowing thing. It's the shifting transfer of kinetic energy to the cold object from the hotter object. That's the heat transfer. Heat energy always flow from hotter to cooler, and it becomes same temperature. Heat is commonly measured in calories. Calories is defined as how many calories are required to increase the temperature of 1 gram of liquid water by 1 degree Celsius. That's the definition of calorie. Calorie is not used in scientific work. We normally use joules. Joules is about 1/4 of a calorie. 1 calorie is equal to 4.184, therefore 1/4 of a calorie. The specific heat is same as specific heat of water. The amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius. Therefore, water has specific heat of 1. Specific heat is characteristic of a compound. Water has the highest specific heat, 1. Ice has little low. Steam has still the same as iron has. The water is a strange compound. It has the highest specific heat. It can absorb most heat. Therefore, oceans absorb a lot of heat during the summers and release it during the winters. Keep the thermal equilibrium. Avoid sudden fluctuation in atmospheric temperature. Now, how do you calculate amount of heat absorbed by your object? Amount of heat absorbed or released by your object is its specific heat times mass times change in temperature. Change in temperature is the final temperature subtracted initial temperature. This is the SH is the specific heat, M is the mass, T1, T2 is final, T1 is initial. So you can calculate how much heat is absorbed by a water sample going from 23 to 95. 95 is the T2. T1 is 23. When you substituted values in the equation, specific heat times mass is equal to temperature difference times temperature difference. So you get 25 kilocalories. Which of the following is a formula used to calculate the kinetic energy of a moving object? What is the equation? Kinetic energy is half mass times velocity squared. We shown that to you in the previous slide. Answer is B. Chemical energy is example of which of the following? What is chemical energy? It's a kinetic or potential. We talk about nuclear energy and chemical energy are potential energies. Chemical energy is associated with electron bonds. Nuclear energy is associated with bonding in the nucleus. Therefore, chemical energy is a potential energy. Nuclear energy is an example of which of the following? Nuclear energy is also potential energy associated with the nucleus. Which of the following is not a form of kinetic energy? Chemical energy is not kinetic energy. Electrical energy is form of kinetic energy. Light, mechanical. Only the chemical energy is not kinetic energy. A is the correct answer. Which of the following is a form of potential energy? Both nuclear and chemical we talked about. Both nuclear and chemical are potential energies. Answer is C. Which of the following is true as a student slide down a water slide? When you go down a water slide, what is true? Kinetic energy decrease? No, as you go down, increase. Potential energy decrease. Total energy increase? No, total energy is conserved. Therefore, potential kinetic energy increase. Potential energy decrease. Therefore, correct answer is B. Oh, what is that? D. None of these. Total energy increase. That's not true. Potential energy. Oh, none of them are true because potential energy decreases. Kinetic energy increases. Therefore, answer is D. Do you guys have a question? What's going on here? Guys, I hear some chatter going on. The answer to which of the following is a student slide down a water slide? Kinetic energy increase, potential energy, all of these. None of these in question 185. So I gave the answers here. Do you see? I'm going to start on chapter. I'm going to start from there next class period. Okay. You guys still there?
Yes.
Just start doing chapter 1 quiz. Okay. Okay. I will see you in the next class on Tuesday. All right. Please sign up the chat box with your name. You guys are okay? Do you have any questions?
You want us to start the quiz today?
Quiz 1.
Uh-huh.
Go to module 1 and you can, I shown in the beginning. Okay?
Okay.
Yeah, time is going fast. All right. Take care, everyone. I will see you on Tuesday. All right.